Hello everybody, myself Akshya and my batchmates of Harmonica and Tanushree. We have done our project on design of a multi-storied office building with various types of foundation under the guidance of Mr. Kalyanasundaram and Mrs. Jayashree. The main aim of our project is to design and analyze a multi-storied office building with various types of foundation. To estimate the cost for each foundation, we have actually designed an office building. If the same office building is to be constructed in some other location where the soil has different safe bearing capacity, for that safe bearing capacity a suitable foundation has been designed. These are some of the literatures we referred. These are some of the modeling details we used in StatPro. This slide shows the key plan of our building. These are some of the loads we applied on our building in StatPro. We have manually calculated a continuous one-way slab for our building. This slide shows the design of a beam we got from StatPro. This slide shows the concrete design of the beam. This slide shows the design of column we got from StatPro. This slide shows the concrete design of our building. This slide shows the building model we have designed in StatPro. These are the results we got from StatPro. We have practically done standard penetration test to find the safe bearing capacity of the soil. SPT is usually used to find the relative density of cohesionless soil. We have done SPT to find the safe bearing capacity of the soil. This is the borehole plan where we did our standard penetration test. These are some of the images we clicked during our SPT test. This slide shows the laboratory test results on the soil sample collected from borehole 1, and this slide shows the sieve analysis, and this slide shows the laboratory test results on the soil sample collected from borehole 2. This slide shows the sieve analysis. This slide shows the chemical analysis test result. This slide shows the SPT test results for borehole 1. This slide shows the SPT details. This slide shows the graphical representation of SPT for borehole 1. This slide shows the SPT test results for borehole 2. And this slide shows the SPT details. This slide shows the graphical representation of SPT for borehole 2. This slide shows the computation of safe bearing capacity from the data we collected, and hence the safe bearing capacity has been calculated as 145 kilonewton per meter square for the site we referred. Here comes the design of foundation. First comes the isolated footing. Isolated footing is usually adopted for a safe bearing capacity of 145 kilonewton per meter square. Load on column has been taken as 953 into 10 to the power of 3 Newton. Hence the total load on column is 10,48,300 Newton. The area of the foundation has been calculated as 7.229 meter square. The size of the footing has been calculated as 2.5 meter into 2.89 meter. Depth of the footing has been calculated as 880 mm. Here comes the check for shear force. Hence the depth we calculated is right, as IV is less than IC. Here comes the reinforcement calculation. Along the longer span, 16 bars are used at a spacing of 62 mm. In the shorter span, 14 bars are used at a spacing of 70 mm. This slide shows the AutoCAD design for isolated footing, and this slide shows the reinforcement details of the isolated footing. Raft foundation is usually designed for a safe bearing capacity of 15 kilonewton per meter square, and hence the length of the raft foundation has been calculated as 41.15 meter and breadth as 22.86 meter. and depth has been calculated as 450 mm. The reinforcement, this slide shows the reinforcement calculation of the footing. 344 bars are provided along length and 192 bars are provided along the width of the footing. This slide shows the AutoCAD design of the raft footing. Then comes the combined footing. Combined footing is usually adopted for a safe bearing capacity of 100 kN per meter square. We have used GW Basic software to design the combined footing. This slide shows the results we obtained from GW Basics. Reinforcement, this slide shows the reinforcement calculation. 18 bars are used in the tension zone and 2 bars are used in the compression zone for beam. This slide shows the AutoCAD design of the combined footing. This slide shows the reinforcement details of the combined footing. Then comes the strip footing. Strip footing is also adopted for a safe bearing capacity of 100 kN per meter square. We have designed strip footing using GW Basic software. These are some of the results we obtained from GW Basics. And this slide shows the reinforcement design for strip footing. 10 bars are used as main bars and 2 bars are used as distribution bars. This slide shows the AutoCAD design of the strip footing. This slide shows the reinforcement details for the strip footing. Here comes the cost estimation for foundations. These are the schedule of rates, which is usually printed in a book format by Public Works Department. For isolated footing, the cost has been estimated as 4,31,076, and the cost for raft footing has been estimated as 14,58,000, and the cost for combined and strip footing has been calculated combinedly. The total cost for combined and strip footing has been calculated as 3,70,159. This slide shows the cost comparison between foundations. Result and conclusion. Thus, the building has been designed and analyzed using StatPro. Standard penetration test has been carried out in site to find the safe bearing capacity of soil. Foundations are designed according to their safe bearing capacity. We have done the design of isolated footing, design of raft footing, design of combined and strip foundation. Thank you.